So let's take a look at this one. We have been reducing our radicals the last few days. Today we are going to continue with that, but I'm going to add variables to it as well. So yesterday we were reducing, we did that little maze to reduce all of them. The variables just add one more step to it. Gabe, can I teach, or do you need to talk about something? All right. So when we are reducing these radicals, then essentially what it's going to do, an exponent tells you how many variables are underneath. And a square root is telling you how many groups of 2 we can form. So we essentially, if the power is even, we just divide it by 2. So when it comes out of the radical, the exponent is just half. If it's odd, we have to break it up. Now, I think this is a little bit confusing, the way it steps out the rules. So I would rather just kind of look at examples and talk about it. Okay? A square root is saying how many groups of 2 can you make? If you have 2 x's, how many groups of 2 can you make? 2 x's form a single group, right? We can take out both of them, makes one group. So when it comes out, it's just x to the first. So it comes out and it's like, how many groups of 2? We have one group of 2. If I have 6 m's, it's a square root. So how many groups of 2 can we form? 3. Kale, did you need your binder? Did you not find it? So if you have 6 m's, then your exponent turns into 3. 3 groups of 2. All right, this time I threw some numbers in there. The square root of 9, what is that? 3. Okay, k squared. If I have 2 k's, how many groups of 2 can I form? 1. So it's a 3k to the first. All right, 64p to the fourth. What is the square root of 64? 8. If we have 4 p's, how many groups of 2 can we form? 2. So 8p squared. All right. Number 5. What is the square root of 100?
10.
What is the square root of x squared? So if I have 2 x's, how many groups of 2 can we form?
1.
Okay, y squared. So if I have 2 y's, how many groups of 2 can I form?
1.
Does everyone understand where I'm getting these? You guys try 6 for me. Take a second, write down what you think that one would be. So what's the square root of 49? If you have 2 a's, how many groups of 2 can you form?
1.
If you have 6 b's, how many groups of 2?
3.
And if you have 4 c's, how many groups of 2?
2.
Let's look at number 7. Y to the 5th. All right, if you're doing your laundry and you come out with 5 socks, how many pairs of socks can you make? 2 pairs of socks, right? So 2 come out. But what happens? You have 1 sock left over, so that 1 stayed underneath. Okay, so if I have 5, I can make 2 groups of 2, and 1's left over, so 1 stays underneath. So number 8, a squared. So what's the square root of a squared? Yeah, it's just an a to the first. If I have 2 a's, I can make 1 group of 2. If I have 3 b's, how many groups of 2 can I form?
1.
1 group, and there is 1 left. So the number that comes out is how many groups. And if it's an odd power, you're always going to have 1 left under the radical. Number 9. X squared y cubed z to the 4th. So if I have 2 x's, how many groups of 2 can we form? 1. Any leftovers? No, if the power's even, there's no leftovers. If I have 3 y's, how many groups of 2?
No.
1. Any leftovers? Yeah, so there's still a y underneath. If I have 4 z's, how many groups of 2? 2. And there are no leftovers. It's only if there is an odd power that's left underneath. I do want to also advise you, so there's some people that will try to write it like this, and it's technically not wrong, but it gets really hard to tell what's under your square root and what's not. So if you could write everything that's not under your square root out in front, and then the square root at the end, that's a little bit easier to read. All right, number 10, what is the square root of 144? Okay, if you have 3 k's, how many groups of 2?
1.
How many left over?
1.
You guys try 11 and 12 for me. So square root of 81 is 9. If I have 7 r's, how many groups of 2 can we form?
3.
And there is an r left underneath. And if you have 4 s's, we can make 2 groups. What's the square root of 196? Okay, if you have 5 c's, how many groups of 2? 2 with 1 left over. And if you have 2 d's, how many groups of 2? 1 and none left over. So it looks like we're doing pretty well with those. Let's add in problems where the coefficient is not a perfect square. So yesterday, the day before, we were doing problems like the square root of 8 and reducing that. Now, we're still reducing the square root of 8, but we have our variables along with it. And just remember that when you do that, the radical is at the very end. Everything that comes out needs to be in front of your radical so that we can read it easily. So when I'm breaking down 8, what perfect square goes into 8?
4 and 2.
So the square root of 4 is 2. So once you do the square root, that radical's gone, and we still have a 2 under the radical. We just have to add in our variables. If you have 6 x's, how many groups of 2?
3.
Are there any leftovers?
No.
No, because it was an even x on it. Okay, so my answer is 2x cubed square root of 2. Make sure the square root of 2 is at the very end. Put the 2x cubed in front. The square root of 50. What perfect square goes into 50?
25.
So 50 is 25 and 2. The square root of 25 is 5. So when you do the square root, that radical goes away. I cannot do the square root of 2, and I can't break it down anymore, so it stays underneath. If you have 2 x's, how many groups of 2 can we form? So an x comes out, and there are no leftovers. So it's 5x radical 2. So just combining what we've been doing the past 2 days with variables. Okay, what about 68? So if I need a perfect square that goes into 68, breaks into 34 and 2, but can I do the square root of either of those? No. So what about, remember our perfect squares. 2 squared is 4. Can you do 68 divided by 4?
Yeah.
So we are looking at these perfect squares. And if you need to on test or quiz, you can make yourself a list of these. You are trying to see, can I divide it by any of these numbers? So that would be 4 and 17. Square root of 4 is 2. Can we break down 17 anymore? No. Remember, sometimes if you don't get the biggest perfect square, you might have to break it down again. But we can't, so the 17 stays underneath. I'm leaving room for my variables. If you have 3 p's, how many groups of 2 can you form? So 1 comes out and there is 1 left over. Because it was an odd, there's 1 left over. Make sure it is clear. Your radical is going over both the 17 and the p there. 45, what can we break that into? Everybody should be trying to find some 9 and 5. The square root of 9 is 3, so that comes out. I'm going to leave space for variables, and I have a 5 under my radical. If I have 11 n's, how many groups of 2 can we form? 5. And since it was odd, there is 1 left over. Alright, let's do one more together, and then I'm going to have you guys try a couple. 27, what can I break that into?
9.
The square root of 9 is 3, so that comes out. 3 stays underneath. If I have 1x, do I have enough to form a group of 2? No, so I don't bring my x's out, it just stays underneath. If I have 16 y's, how many groups of 2?
8.
And none left over. Okay, I want you guys to try. I'm going to give you some time. If you get through all 3, great, but get through as many as you can. 180. So I need a perfect square that goes into 180. What could we do? 36 and 5. The square root of 36 is 6. And the 5 stays underneath. Now, I saw some people that did 9 and 20. Are you wrong? No, you just have to keep reducing. The square root of 9 is 3, but 20 can break into 4 and 5. And the square root of 4 is 2. 2 times 3 gives you 6. So if you don't get the biggest perfect square, you just have to reduce again. You still get to the same point. With my variables, I have 3 x's, so how many groups of 2? 2, and there is 1 left over because the power was off. With my y's,
Only 1 group.
oh yeah, sorry, 1 group of 2 with 1 left over. With my y's, if I have 8 y's, how many groups of 2? 4 groups of 2, it was an even power, there are none left over. So 6x y to the 4th and a square root of 5x. Make sure all the numbers outside your radical are in front and the radical extends over both the 5 and the x. 160, we can break into 16 and 10. Square root of 16 is 4, and we keep a square root of 10. If we have 3 a's, how many groups of 2? 1 group of 2 and 1 left over. 6 b's would give me 3 groups of 2. And last problem of the day, 108. What can we break that into? 36 and 3. Square root of 36 is 6. 3 stays underneath. If I have 18 r's, that makes 9 groups of 2. If I have 13 s's, we would have 6 groups of 2 and 1 left over. All right, do we need more? Okay, so I'm going to give you a handout. I am fine if you want to work